In this lesson, we will learn how to show the text on LCD screen. Then we will see how we can move the text on LCD screen. We will run a counter which will count from 0 to 10. When the counter reset, it will start again from 0. We will then scroll the text on LCD screen from left to right and then from right to left. I'm sure you will enjoy making cool projects using LCD in your next Arduino project. Hook up the circuit as it's shown in a picture below. I can quickly walk you through the connection between Arduino and LCD module. Believe me, it's not very difficult. It just looks very complex, that's it. Now let's connect the LCD pin number 1, which is a VSS pin. We're going to connect to the Arduino ground pin. So the pin number 1 of a LCD will connect to the GND ground pin of Arduino. LCD pin number 2, which is a VDD pin, will going to connect to the plus 5 volt pin of the Arduino. LCD pin number 3, which is a V0, will going to connect to the potentiometer, the center pin of the potentiometer. So this V0 pin will going to use to adjust the contrast of the LCD. What it actually does is, when we connect a potentiometer, usually we will be using a 10 kilo ohm potentiometer, that is a recommended one, 10k pot, a 10k potentiometer. This 10k pot will form a voltage divider circuit, and using this voltage divider circuit, when we rotate the potentiometer, we can able to change the contrast, change the brightness of the LCD, so that we can able to see clearly. We can adjust the light of the LCD to have the better view of the sensor data and text and everything. The LCD pin number 4, which is the RS pin, will going to connect to the Arduino pin number 12. And LCD pin number 5, the pin number 5 on LCD, which is a RW pin, read write pin, which will anyways going to connect to the ground of the Arduino. LCD pin number 6, which is an enable pin, will going to connect to the Arduino pin 11. LCD pin number 7, 8 and 9, which is a D0, D1, D2, D3 respectively. This all would not going to connect to anything. So pin number 7, 8, 9 and 10 on LCD will remains not connected. So we will be keeping this pins open, so there should not be anything connected to this pin. So LCD pin number 11, which is a D4 pin, will going to connect to the Arduino pin number 5. LCD pin 12, which is a D5 pin, will going to connect to the Arduino pin number 4. LCD pin 13, which is a D6, will going to connect to the Arduino pin number 3. LCD pin 14, which is a D7 pin on LCD, will going to connect to the Arduino pin number 2. So in short, LCD pin 11, 12, 13, 14 will going to connect to Arduino pin 5, 4, 3, 2 respectively. So what else remain is on the LCD side is pin number 15 and 16. So pin number 15 is a anode, which will going to connect to the 5 volt plus 5 volt pin of Arduino via 220 ohm resistor, and LCD pin number 16, which is a K for cathode, will going to connect to the ground pin. Now this pin number 15 and 16 will be used for the backlight, and this backlight will be very important when you want to see the data in the night time, in the evening, or when it's a little bit dark. Then you can able to see the little bit light in the backlight, that they used to call it as a backlight, and there you can see precisely the data on your LCD screen. I hope these connections are clear. The only thing that you have to make sure is don't forget to connect the 10 kilo ohm potentiometer to V0 pin, which is a LCD pin number 3, and make sure you also connect a 220 ohm resistor across the pin number 15 of LCD when you're going to connect to the plus 5 volt of Arduino. Now when we are done with all these connections, the first step is to make sure whether the circuit works or not. Now as you can see in this video, there is an LCD 16x2 character LCD which is connected to Arduino Uno, and as you can see, I have hooked up all the pins from the LCD from 0 to 16 to Arduino Uno, and that's how you complete the circuit. Now before we go ahead and write a program, the first step is to make sure whether the LCD works fine or not. And if you remember from the circuit schematic and the connection that I have explained earlier, you might know this pin number 16 and 15. 16 and 15. So 16 is a ground and 15 is the is plus 5 volts, which represent anode and cathode, right? So plus 5 volts is a anode, and this ground is a cathode, and that is for the backlight. Pin number 16 and 15 is for backlight. So if I remove this 15 and 16 pin, you can able to see backlight will turn off. Okay, and as you can see, there's no light now on our LCD, so we cannot able to see the text on LCD in the night or in the evening. So let's turn on the backlight once again. Let me put this again, and now you can able to make sure now your backlight function works. The second thing to make sure when you test your LCD from the box is to check whether you can able to change the brightness of the LCD or not. This is the basic function, and as you can see, there is a potentiometer, 10 kilo ohm potentiometer that I have connected to V0 pin, which is I think 1 2 3, I think the third number pin, hopefully. And if I, as you can see, there is no pixel, there is no boxes on LCD. As soon as I reduce the resistance, as I move the potentiometer around, and you can able to see there will be the boxes will coming up, and as you can see now the boxes are came on LCD. And if I move this potentiometer other way around, then you can able to see this boxes will go off, right? So your pixel, what I can call it as a boxes, because I love to call it as a boxes, this pixel or the boxes will come and goes as you move this potentiometer. So you can able to control the brightness of the LCD, so you can able to change the way and look and feel that you like. Right, so if this two function works, then you can make sure, you can say like your LCD works fine, and then you can hook up these data pins from, let's say, I think it's from D5 to D8, and then other control pins, and you can now able to write a code and test your circuit. So let's start writing a code, and as you can see on my screen, I have a blank sketch Arduino program on my screen. The first thing we have to include the library, and the library that we're going to use here is a liquid crystal. So we have to say include, and the name of the library, liquid crystal .h. This is the library that I already have mentioned, that this is a built-in library that we can use with Arduino in order to interface 16:2 character LCD. The next step is we have to define the pin numbers, right? Means which pin on LCD will going to connect to the which pin on Arduino. That's how we will going to define the interface between LCD module and Arduino, so that we can able to control this LCD through the Arduino. So the first pin is constant integer. We have to define RS, and that will be 12. So pin number 12 will from Arduino will going to connect to the RS pin. Constant integer, another variable, give it the name en for enable, and that will be connected to pin number 11. We need some more constant integer, d5, that will connect to 5, and I will simply just copy this and then I will replicate it for a couple of times. So d5, then d4, d3, and d2. Likewise, I have to say like 4, 3, and 2. So that's all we have to do. The next step is we have to define an object from the liquid crystal library, because that's the this liquid crystal.h is a header file where we have the class. So I will say liquid crystal, and then I will make the object LCD, and I would going to pass all those pin number, and that are the RS for register select, enable, then D5, D4 pin, D3, and in the end D2. Once this is done, we just have to make the default loops. So we just have to define void setup function, which every Arduino sketch has to have. then we have to have a loop function, right? So this completes the basic skeleton of the code. In the setup function, we have to define, initialize the LCD, and we must say to initialize the LCD dot begin, and then we have to pass what is the type of this LCD, and LCD is 16 by 2 character LCD, so I must say 16 comma 2 for 16 by 2 LCD. And the first thing that we want to do with LCD is we just want to print the message hello on the LCD screen. So we'll say LCD dot print, and then I must have to type the string that I want to print, here in this case hello. Once this is done, we just upload the sketch and see if we can able to show this hello text on the LCD screen, and make sure the place where this hello has been shown on the LCD, because it's a 16 by 2 character LCD, so there are a lot of pixels there, a lot of different numbers for every column and every row. So this will take the 0, 0, that means the first row and first column by default. If we want to change this, we can change this programmatically, but for this this very basic testing, we just keep as it is, and we just make sure whether we have the Arduino board selected, and then make sure the COM port. If everything is okay, then press the upload button upper left corner and see if you can able to show this hello string on the LCD module. And on the LCD module, of course, it's been shown on the upper left corner of the LCD. As you can see right now, hello has been printed on the upper left corner of the LCD screen. So what if I want to move this LCD, this text or this message hello, I want to move it, let's say a 4 pixel or 5 pixel apart. So I must say LCD dot set cursor. So this is a function that will allow us to change the position of a text or the character on the LCD screen, and it takes a parameter. So I have to say like 5 because I want to move the 5 positions, and 0 because it's the first row, right? 0, 1, so it's the first row. So if I upload this program, you can able to see this hello will be shift 5 places to the right. And as you can see right now, hello comes to the center, and your edge, if you follow, it has been moved from left to right 5 places, 5 pixels, right? So I hope now you may be familiar with how to show the message or the text on the LCD, and how we can able to move the text or the characters left and right wherever we want. So the next task is to do something more meaningful than what we have done as of now. So what we do is we will make a counter that will count from 0 to 10, and then again will count from 0 to 10. Okay, so that will be more meaningful, and we will be using both of those rows, 0 and 1 both. So what I'm gonna do is I will take this code lcd.setCursor and lcd.print, and I will paste this code into the loop function. So once I take this in a loop function, I have to select entire text and set it to auto align. And then what we have to do is I just have to create a for loop. Let's say I just have to define one variable here, and this will be the count variable. Let's say I define integer count, and it's a 0 by default, and I can take here in the for loop this count is equal to 0, and then we'll make, if the count is less than or equals to 10, then we want this count to be incremented always. And then in the curly braces we will say lcd.print, and we have to print this count, the value into the count, and count value will be keep increasing from 0 to 1, right? And we want to increment this after every 1 second of the delay. That will take, let's say, 1000 milliseconds. One more very important thing here that we have to mention is where exactly we want to show this the value into the count variable, and for that we have to say like lcd dot set cursor, and then we have to mention where we want to show. It's the, let's say, a 7th place, and into the second row, and second row is 1 because the first row is 0. The second, you might wonder, let's look at this. So the first row is 0, the second row is 1. So we want to show this count value onto the second row and the 7th place, right? So that's how it's been done. So let me upload the sketch and see if I can able to show. One more thing I think I forgot to mention here is I have to say lcd.clear because I have to clear all the time, otherwise that will overlap the text. And now I think the code looks better. I can save this code and let me Control A and Control T, so this will do auto alignment for the code. And let's upload the sketch by pressing upload button on the upper left corner. And it shows like somewhere I forgot to give semicolon, so I have to check where I forgot. Let me see. Okay, here I forgot the semicolon, and this is the extra. But let me hit upload button once again and see if I can able to make this work. Okay, so it seems to be working. The only problem is I forgot to change this to the counter, right? So I can say counter rather than hello, and now I can upload the sketch and I will show you. It will show exactly the same result that what I expected. And as you can see, I have a counter which counts from 0 to 10, and then it will reset back to 0 and it will again start counting from 0 to 10. This is what we wanted to do, right? That's all. Perfect. Now when it comes to create a scrolling effect, I mean, if you want to scroll the text from left to right and from right to left, we can even do this with this LCD. And for this I can remove all the code that I have written, and I would going to write cd LCD, then print, and I will take the previous message that we used to print, a simple one, hello, and we're going to scroll this hello text from left to right and right to left. And for this we have to come back to the loop function again, and we have to create a for loop. Let's say if I say for integer I equals to 0, and I must say if I is less than 16, then I will increment this I variable, and then in the curly braces I must have to write a function, define how I want to move this text. I want to move this text to right, so I must say lcd dot scroll display right. Okay, and if that is the case, scroll display right, and then I must give the delay at what time interval I want to scroll. So after 250 milliseconds I want to move one place to the right, means 1 pixel to the right. And once this is done, then we must have to write another. So let's test this code first. If this works fine, then we can able to see this hello will move from left to right. So let me upload the sketch. So as we can see, like this hello is scrolling from left to right, and you can see again it came. Perfect. So now we can able to scroll the text from left to right. Now we have to scroll this text. When it moves from left to right, we have to take it from right to left again. So what we're gonna do is we can have one more for loop, and we'll get an integer. Let's say this time we can take j, right? And we can say if j is greater than 0, then we'll say j minus minus. If integer I, let's take it I, do not mess with these things. If I is equal to 16, because we are taking 16, and I minus minus, and then we're going to write lcd dot scroll display to the left, and again we have to say delay of 250 milliseconds, and this will looks okay for now. Okay, cool, looks okay. So let me Control A, Control T for aligning code. That will looks better. So this for loop will scroll the text from left to right, and then again this second for loop will take this text from right to the left. And when I upload the sketch, we can able to see the impact of this program where our hello will scroll it from left to right and from right to left. As you can see, this text is scrolling from left to right and from right to left. Perfect, right? This is what we have been expecting. So now you know how you can able to send the data onto LCD, how you can show even the sensor data. Maybe in the next video we're going to show a temperature or maybe some other light sensor or any sensor data on the LCD screen, and we can able to show the data. We can able to create a different effect like a blinking. We can move the cursor here and there. We can even create a scrolling effect and many more things. You can just play around this LCD and create really cool projects. I hope you will find this video educational and entertaining. We'll see us in the next video. Thank you for watching, and bye bye for now.